Welcome back, dear students. So today we are starting a very new and very important chapter from calculus, and the name of the chapter is derivatives. Okay, now this particular topic has already been introduced in your kinematics from physics. Okay, now in that particular chapter, that is in kinematics, you learnt that derivatives, or also known as differentiability of a function, is the rate of change of some quantity with respect to some parameter. That's what you have understood. For example, speed. In kinematics, you defined speed as a rate of change of displacement. Yes, and you said that speed is written as dx by dt. Yes, that's what you mentioned, isn't it? Actually, this is what? This is called the derivative. This is a derivative. Okay, now let's forget about this. Now, let's try to understand what is the definition of derivative at a point, or differentiability of a function at a point. Okay, so suppose f is a real valued function. Now you know what is the meaning of real valued. Yes, that means if your domain and range of a function are both real numbers, those kind of functions are known as real valued functions. Okay, and C is a point in its domain. So basically there's a function f from R to R, okay, where R is your domain and this R is your codomain. Okay, now this C is a point in its domain, so C is coming from this. Okay, now f is differential at point C. So you want to check the differentiability of this function at point C. Now the function is said to be differentiable at point C if the following limit exists. Now the following limit is this particular limit. Okay, so if this limit exists, then only your function is differentiable at point C. Now, since you have already done limit of a function, let me again repeat it for you. Okay, now suppose if I say that limit x tends to C fx exists, if I say that this limit exists, this means that the left hand limit and right hand limit both are equal. Okay, so if these two left hand limit and right hand limit are equal for this limit, then we say that this limit exists. Okay, so let's quickly write down the definition of left hand limit. Okay, so you know what is the meaning of this. So C is a point, okay, and this is a point x which is approaching towards C. Okay, so if the x approaches to C from left, that particular x, you know, suppose if this x is here, which is approaching to a C, this x is less than C. Okay, so that's why this is written as limit x tends to C from left. So from left means from negative side. So that's why I have to write C minus. So this is written as fx. So whenever you say this, this means that this is your left hand limit. Now, if you want to get rid of this negative sign, there's one more method which can be introduced here. So what you have to do here is limit x, instead of x and all, you will introduce a very small quantity h. Okay, so h is a very small positive quantity. It can be like 0.0001. Okay, so h is a very small quantity which is close to 0. Okay, now see here, I have replaced x with h, isn't it? So here also this x has to be replaced by h. Now how you are going to replace? You have to replace in this way. Now see here, you know that this x is going towards C from left, that means x is less than C, right? So within this f, whatever quantity is there, that particular quantity is less than C, isn't it? Now this quantity is also less than C. You know why? because if h is very close to 0 and it is a positive quantity, remember, let me take h equals to 0.01 or 0.1, let me take, okay. Now this c minus h will always be less than c. For example, if I take c to be 2, okay, then c, that is 2 minus 0.1 is 1.9. So altogether this is 1.9, and this 1.9 is less than 2, isn't it? That is, this is less than c. So this x is also less than c. This term is also less than c. So basically these two represent the same thing. All right. Now let's go to right hand limit. So right hand limit means there is a point c and you are approaching to c from the right hand side. So that means if this x is coming from right, so you clearly see that this x is greater than c, isn't it? So if this is so, then we can write the definition as limit x tends to c from positive side fx. Now again, if I replace this x by h, which is a very small positive quantity, then you know that this x is greater than c, isn't it? Yes. So here also I do the same, but here I am going to put c plus h, and obviously this quantity will be greater than c, as you are adding a positive quantity out here. So that means whenever this quantity, that is left hand limit, is equal to this quantity, that is right hand limit, then we say that this limit exists. Okay. Now back to our work, that is the definition. So definition is saying that this limit should exist. That means the left hand limit of this and the right hand limit of this must exist, and they must be equal to each other. Okay. Now let me quickly write down the definition for this. Okay. So as I said here, if this limit exists, then what happens? You have left hand limit. So this time I'm not going to call it to be LHL, I'm going to call it LHD, left hand derivative. Okay. So that means left hand derivative must be equals to right hand derivative in this case. Okay. Now let's see what is the definition for left hand derivative. So where left hand derivative, so you know that left hand derivative is given by limit x tends to c negative, yes, fx minus fc by x minus c. So this is your left hand derivative. Now let's redefine this particular thing in this way. Okay. So I'm going to introduce a new thing, that is limit h tends to 0. Okay. So I'm going to erase this part. So I hope you understood this. Okay. So this is my left hand limit. The upper one is left hand limit and the lower one is right hand limit. Okay. So when I introduce this, you know that fx became this much, isn't it? So we have f of c minus h minus fc. Will there be any change in fc? No, because we have changed x, not c. So that's why the c will remain as it is. All right. So this is my fc divided by, so remember x became c minus h. So that's why this x will also becomes c minus h, and we already have minus c out here. So you see that this and this gets cancelled. So ultimately your definition for left hand derivative will be, see here carefully. Okay, let me remove this also then. So your definition for left hand limit becomes, okay, so this minus h is there, no? So if you want to keep it outside, that's also fine. If you don't want to keep it, that's also fine for me. So we had limit h tends to 0 f of c minus h minus f of c divided by minus h. So this is your definition for left hand derivative, remember. Okay. And right hand derivative will be equals to, in the same way, limit x tends to c plus fx minus fc x minus c. So this has to be redesigned now. So I'm introducing a positive quantity h, very small quantity. Okay, and you know that this f of x earlier changed into f of c plus h. So minus, as usual, this fc will remain as it is. So this x, you know, this x is there, this x has changed into c plus h. So that's why I have to write c plus h here. And we have got minus c also, so let's write minus c also here. So you see that c and minus c gets cancelled. So ultimately your definition becomes limit h tends to 0 f of c plus h minus f of c divided by h. All right, so left hand derivative will be this much, right hand derivative will be this much. All right, so if these two are equal, then we say that function f is differentiable at point C. Now I have to give some notation as well, isn't it? Okay, I have to give some notation for this. Now if this limit exists, remember, if this limit exists, then we denote this limit or the derivative by f dash of c. Remember, because we are differentiating or finding the derivative at point C, so that's why you have to write c here. Okay, so this is your derivative. Okay, and this is in fact also known as first principle. This is also known as first principle. Okay, so you can make a note of it. So this is also known as first principle, because sometimes, you know, in exam they will ask you find a derivative of some function they will give using first principle. That means you have to make use of this definition and find the derivative of the given function. Okay, so this is all about your definition. Now let's talk about few more notations. Suppose if your function is given in this way, y equals to fx. Remember, y is independent variable, x is depending variable, because f is a function of x means this y is depending on x. Okay, so if your function is given in this way, then you know that derivative is given by f dash, yes, and another notation will be dy by dx also. Okay, so this is also one notation for derivative. There are some other also. For example, you write y1 also. Okay, so if y equals to fx is given and y1 is also seen somewhere, this means that y1 is the derivative of this function fx. Okay, so you have to make note of that. Okay, so with that much, pause the video, note down the important points so that we can begin with the problems. Alright, dear students, let's see few examples, very simple examples in fact. So the first question says, find the derivative of fx equals to 3x at x equals to 2. Okay, so they are asking the derivative of this function, which is represented by f dash, as I said, at the point 2, right? Okay, so you are finding f dash of 2, and as per the definition, this will be equals to limit x tends to c. And what is the value of c? C is 2, isn't it? You are checking, or you are finding derivative at point 2, so that's why here you have to write 2. So the definition becomes f of x minus f of 2 divided by x minus c, that is this much. All right, so let's quickly evaluate this. So this becomes limit x tends to 2. What is fx? fx is 3x minus, now f of 2, instead of x you have 2, isn't it? So here also you have to write, instead of x you have to write 2. So this becomes 3 into 2, all right, divided by x minus 2. Now you people are quite familiar with finding the limits, right? So you see that 3 is common in the numerator, so that 3 is in fact a constant, right? So the constant can be kept outside limit. So I am writing 3 outside the limit sign. So I have to write limit x tends to 2 is there. So 3 is gone, so only x is left. From here also 3 is gone, only 2 is left. Divided by, we have got x minus 2. So both of them gets cancelled. So we don't have anything here, isn't it? Only 1 is there. So since there is no x which can be substituted with the value 2, so that's why, since we don't have any x here, so we'll directly write this as 3 into 1, because we have got 2 by x, this by this is 1 by 1, which is 1. So this turns out to be equal to 3. So my first answer, is 3. Okay, so let's see another problem. So this is my second problem for the day. It says that function is given to be x square minus 2, and you have to check, or you have to find the derivative at point x equals to 10. Okay, so you have to find f dash of, in fact, 10. So this becomes limit x tends to c, that is 10 fx minus f2 divided by, I'm sorry, not f2, this is f10 this time. So x minus 10, right? So let's put the values. So limit x tends to 10. What is fx? Fx is x square minus 2, right? Minus, what is f10? So f10 becomes 10 square minus 2, right? Okay. So this is my x minus 10 itself here. Okay, remember that. Okay, so let's simplify this now. So limit x tends to 10. So this becomes x square minus 2 minus 10 square plus 2, isn't it? In the numerator we get this. So in the denominator we have x minus 10. So you see that this and this gets cancelled. So you have x square minus 10 square. Isn't it a square minus b square? Yes. So this can be written as limit x tends to 10. So a square minus b square can be written as a minus b into a plus b. So divided by, we have x minus 10, and you see that these two gets cancelled. Now you have only x plus 10, right? So let's put the value now. So if you put the value of x to be 10 here, then this becomes x is 10 plus we have got 10 here, so 10 plus 10 becomes 20. So what is my answer for the second question? My answer is 20. Now third one is very important for you. Let's see how to find this. So you have to find the derivative of fx equals to sine x this time at x equals to pi by 2. Okay, so f dash of pi by 2, that's what the question is asking, isn't it? So the formula says it is limit x tends to c, c is pi by 2, fx minus fc divided by x minus c, right? Okay, so this is limit x tends to pi by 2. So this is my sine x minus sine c divided by x minus c. Okay, now whenever you have this problem, trigonometric limit, then make sure that you write 0 out here. Okay, and whenever you make use of, or you make it 0, you can either go for two definitions. See, you have got two definitions. One is definition for left hand derivative and another definition is for right hand derivative. Okay, so it's always better to go for right hand derivative definition, since you know that this limit exists. Question already says that find the derivative. If it is already existing, then only they'll ask this way, isn't it? So they are already saying that they, or the derivative is existing, or the limit is existing. That means the value of this will be equal to left hand derivative and they will be equal to right hand derivative. So that's why it's always better, to go for right hand derivative whenever you see trigonometric limit. Keep that in mind. Okay, so if I do that, then this becomes limit. Remember the definition says it tends to 0, isn't it? F of c minus h, right? Or in other words, I can say that x is substituted with c plus h. Yes, and what is c? C is pi by 2. So this is pi by 2 plus h. Okay, minus, we don't have to substitute anything out here, so it will remain as it is. So here we have pi by 2. Okay, I'm sorry, this c is there, right? So c is actually pi by 2. You can directly write pi by 2 here. all right. So let me write pi by 2 here, okay. So it is actually not this thing, this is pi by 2, okay. So this sine pi by 2 is how much? It is equal to 1, yes. So we have pi by 2 plus h minus pi by 2. Remember, x is substituted by pi by 2 plus h, okay. So this and this also gets cancelled. So sine 90 plus theta, you know what is the formula for this? Sine 90 plus theta is 90, okay. So what you do is, first go here, so 90 means still here, yes, plus means you will go front, so that means you are landing up in the second quadrant, and in second quadrant your value for sine will be positive, okay. And you have to write, see, whenever you have got pi by 2, 3 pi by 2, 5 pi by 2, then this sign becomes cos, okay. If you don't understand that, the only formula that I can say here is sine 90 plus theta will be cos theta. That's all I can say, okay. So if I write that, then this becomes limit h tends to 0. So this is cos theta, that is theta is here. What is theta? Theta is h, isn't it? So this is cos h minus 1 divided by h. Now you know what do you do here? Whenever you see this, you will try to convert it into half angle. You remember half angle? So what you do is, you use here this formula, okay. So you know that 2 sine square theta is equals to 1 minus cos 2 theta, isn't it? So this formula has to be used here, okay. So for that I have to take minus common, isn't it? So let me take out minus common. So if I take minus common, then this becomes limit h tends to 0. So this becomes this becomes 1 minus cos h is there, right? So can I write this h as 2 into h by 2? Definitely, divided by we have h, right? Okay, so let me erase this part. I don't have space. I think I won't be able to complete this problem in this. Okay, fine. So we have, let me do it here. Okay, so this is equal to minus, so limit h tends to 0, h tends to 0. So you know what is this? Using this formula, this is equals to 2 sine square theta. And what is theta actually? Theta is h by 2, right? So this is h by 2 divided by, what do we have? We have h, all right. Now there's one more formula. The formula is limit x tends to 0 sine x by x will be equals to how much? 1. Yes, do you remember this formula? Okay, so let's apply that formula here. Okay, so in order to apply that formula, I must write this as minus, okay, so this 2 is constant, I have to keep it outside, limit, okay, so h tends to 0. Now here we have got square, you know, so this I'm making it sine h by 2 divided by h by 2 whole square. Now you must be wondering, we have only h here, but you are writing h square. So in order to balance it, what will I do is, I will write here into, actually I have to write here, I don't have space, I am writing here, okay. So I will write h by 4, okay. Now why 4? Because we have written 2 square also, no, right? So 2 square is also written, so we have to take care of that also. So 2 square can be balanced if I keep 4 here. You can check by yourself. So this 2, this 4 comes outside, so becomes minus 2 by 4, okay. Now how much is this? Actually, in fact, this limit also can be included here, okay. So this is limit h tends to 0, so this by this becomes 1, isn't it? So this is actually how much? 1 square into, so we have limit h tends to 0, we have got h also, isn't it? We have to take care of h also. Okay, so ultimately this is 1 by 2, that's okay, but this becomes, see here, this is 1 by 2 into 1 into, now how much is this? This is 0, isn't it? So this is 0, so that's why ultimately my answer turns out to be 0. So that means the derivative of this function at x equals to pi by 2 will be 0. Okay, so that's how we do, or we find the derivative of a given function. So you may pause the video and note it down. Okay, now let me take this problem. So this is my, okay, again we have to use the first principle, and here they haven't said that this is my fx equals to this much. You have to assume that. Okay, so I'll write let fx is equal to 1 by root x. Okay, so if this is my fx, you are asked to differentiate using first principle. That means you are asked to find f dash. Now you must be wondering at which point. So if this is not given to you, then you will always take that point to be point C. Okay, so as per the definition, we have limit x tends to c fx minus fc divided by x minus c. So this is the definition, right? Okay, so let's apply this definition then. So we have equals to limit x tends to c, fx is 1 by root x minus 1 by fc becomes 1 by root c, right? Divided by, we have x minus c. Okay, so now you have to simplify the numerator. Let's simplify this. So we get, okay, so we have limit x tends to c. Okay, so in the numerator only okay, so can I write this as this by 1? Yes. Okay, so let's simplify the numerator. The LCM is square root of x into square root of c. So divide this LCM by square root of x, you will get square root of c. So square root of c into 1 is square root of c minus, okay, so divide this by square root of c, you will get square root of x. So this into 1 is square root of x. Now this division is converted into multiplication. You know, this was x minus c by 1 becomes 1 by x minus c. Okay, now can I write this x minus c as square root of x square minus square root of c square? Can I do that? Yes, definitely. Why am I doing that? Because I want to get rid of this. Or in other words, what you can do here is you can rationalize the numerator. Okay, so let me do that only. So let me rationalize the numerator, because you might get confused out here. So if I write this as 1 by x minus c, and if you want to rationalize the numerator, then you will multiply it by square root of c plus square root of x divided by square root of c plus square root of x. Okay, so let's see. Limit x tends to c. So a minus b into a plus b. So this is a square minus b square. So in the denominator we have this square root of xc, right? Yes, this x minus c, this is square root of c plus square root of x. Okay, now see here carefully. So this limit x tends to c. Now this is c minus x, right? Yes. Okay, so we have square root of xc. Now here you have got x minus c, and if you take out minus common, then it becomes c minus x, isn't it? So that minus I am keeping it outside. Okay, so minus is taken common, and the denominator contains one more term, that is square root of c plus square root of x. Now you see that this and this gets cancelled. Yes, so that's why this will be equal to minus limit x tends to c. So we have got 1 in the numerator. In the denominator we have square root of xc into square root of c plus square root of x. Now can we substitute the value of x to be c? Yes, because we don't have any problem here. Like we don't get 0 by 0, infinity by infinity forms and all. We don't get any indeterminate form, right? We call 0 by 0, infinity by infinity. All of them will be called by the name indeterminate form. So since it is not in indeterminate form, you can directly substitute the value of x to be c. So if I do that, then this becomes minus 1 by square root of c into c. Instead of x, I have written c. So this becomes square root of c plus square root of c, right? So this is c into c is c square. So that's why this is 1 by c. And what is this? C, root c plus root c is 2 root c. So this becomes 2 c root c. Okay, so this will be your f dash of c. So pause the video and note it down. Okay, so this is my next question. This is my fx, right? So let me call this as fx. So let fx is equal to x square minus 1 by x. So you want to find f dash of c, which is given by limit x tends to c. Now let me directly write down the formula of the value. Okay, so fx minus fc. So what is fx? Fx is x square minus 1 by x minus, you have to write fc, and fc becomes c square minus 1 by c. Yes, divided by x minus c. Is this true? Yes. Okay, so let's quickly evaluate this. So this is limit x tends to c. So as usual, I am writing this as this much. So let me simplify the numerator. So the LCM is xc. So divide this by x, you will get c. So you will get c into x square minus 1 minus, similarly you will have x minus x into c square minus 1. So this is the simplified version of numerator. Now I am writing this line, that is division, as multiplication. This becomes 1 by x minus c, right? Okay, now limit x tends to c. Let's open up the bracket. So we get cx square minus c minus xc square minus into minus plus x, right? So in the numerator we get this much, in the denominator we have xc into x minus c. Yes, okay. Now you know I'm getting problem with only x minus c, because when you put x equals to c, then this becomes 0, which becomes indeterminate form. Okay, so I want to get rid of this. Now in order to get rid of this, let's try to factorize numerator and check whether we get this much or not. If we are able to get x minus c, then they will get cancelled. So that's what I am trying here. Okay, so in order to do that, what am I going to do is, let me take these two things together. Okay, so if I keep them together, then you see that there is something common. What is common out there? You see that cx is common here. So cx is common. So cx is gone, and what is left from here? Only x is left. Yes. From here also we have got cx already gone outside. So only minus c is left here. Okay. Now here we have got, okay, so x minus c is left. X minus c is left, isn't it? And in the denominator we have xc into x minus c. Okay, so this becomes equal to limit x tends to c is already there. Now from here and here, what is common? X minus c is common, right? So x minus c is common. So what is left from here? Only cx is left. So only cx is left, and from the next part, what is left? Only 1 is left. So plus 1 is left, divided by, we have xc into x minus c. Check. Isn't it true? Okay, so this and this gets cancelled. So we had limit x tends to c, cx plus 1 xc. Now substitute the value of x, you won't find any indeterminate form. That means your answer will turn out to be c into x is c plus 1 c into c. So that is, your answer is c square plus 1 by c square. This is your answer for this particular question. So pause the video and note it down. Okay, so let's have this problem now. So this is your fx. Okay, so f dash of c will turn out to limit x tends to c fx, that is x square plus 1 into x minus 5 minus, this is my fx, minus you have to write fc. So fc becomes, okay, so instead of x you have to just replace by c. So this becomes c square plus 1 c minus 5, yes, divided by x minus c. Simple. Let's open up the bracket and see how much do we get. So we get limit x tends to c. So this is, okay, so let's multiply this. So x into x square, x cube plus x, okay, so minus 5x square minus 5, similarly minus, you will get, okay, so since there is minus sign, all the sign will get opposite sign, okay, please remember. For example, c into c is c cube, but our sign will be minus. So c into 1 is c, the sign is plus, but because of minus it becomes minus c, okay. Similarly you will have plus 5c square plus 5, okay, divided by x minus c, and you see that this and this gets cancelled. All right, now let's group together the similar quantity, that is x cube minus c cube. So this is one group. Another group is this one, okay. So let me write minus 5 common. So if I do that, then becomes x square minus c square, and we have got x minus c divided by x minus c, okay. Now a cube minus b cube, what is the formula of that? I think the formula says a cube minus b cube is a minus b, that is x minus c, into a square plus ab plus b square. I think this is the formula. Minus 5, so this is a minus b into a plus b, right? So x minus c into x plus c, and we already have x plus c out here, okay. Now see here carefully, we have x minus c, right? So in the denominator we have x minus c. Now if you take x minus c common from the numerator, then you see that x minus c is common. So what is left? So from the first part we have x square plus xc plus c square minus 5 into, okay, see here, so this is gone. So minus 5, x minus into plus is minus, so for this 5c, so this becomes 1, as, I'm sorry, this is x minus c, this is x minus c, so this x minus c is gone, so only 1 is left, right, divided by, we have x minus c. So x minus c and x minus c, they gets cancelled. Now we don't have anything in the denominator, you are free of denominator. Now you can happily substitute the value of x to be c here, okay. So let's substitute and see how much do we get. So we get, so this is c square plus c into c plus c square minus 5 into x, that is 5c minus 5c plus 1, yes, okay. So this is c square, this is also c square, this is also c square, so that's why this is 3c square, this is 5c, it becomes minus 10c plus 1. So this is my answer for this particular question. So pause the video and note it down. So here we have another one, so let me call this to be fx. So we need to find f dash of c, which says limit x tends to c fx, that is e to the power ax plus b minus fc, fx minus fc. So fc becomes e to the power ac plus b. Instead of x, just write c divided by x minus c. Okay, so before we get into the problem, I want to mention one formula, very important formula, that is limit x tends to 0 e to the power x minus 1 by x will be equals to 1. Okay, so let's try to make use of this particular formula here. Now for that, you see that there has to be 0, and we already, in fact we are expert in doing that. How to include 0, we already know that. Make use of right hand derivative. Okay, so if I make use of that, then this becomes limit h tends to 0 e to the power a. Now instead of x, how much do we write? We write h plus c or c plus h, right? So we'll write c plus h here plus b is there minus e to the power ac plus b. We don't have any x, so we won't substitute anything here. Remember, this is b, not h, divided by, so this is c plus h minus c, so these two gets cancelled. So we have limit h tends to 0. So let's see how much is this. So this is e to the power ac plus b, I'm keeping it this much, into e to the power ah. Can I do that? Yes, because ultimately you will get, if you combine these two, you will get this much only. Please check. Okay, and you see that this is present here as well, isn't it? So if I take this as common, then I can write this as this much. All right, divided by, we have got h. Now, does this have any h quantity? This particular quantity is independent of h. So that's why this becomes a constant which can be kept outside the limit. Okay, so that's why this becomes e to the power ac plus b, and we have limit h tends to 0 e to the power ah minus 1 divided by h. Now if you compare this formula with this, if there is x, here also we need to have x, but here we see that there is a to ah, not only x, but we have ah. So if it is ah here, we must have a here also. So let me put a here, and I have to substitute one a here, because I have written this a extra, right? So in order to balance this, I'll put one a here. Okay, so a is a constant, it will be kept outside, so a into this becomes a e to the power ac plus b, and how much is this? This quantity is exactly 1, so that's why into 1 has to be written. So that's why your answer for this will be a into e to the power ac plus b. So you may pause the video and note it down. Okay, so now we have the given function is sine 2x minus 3. So this is my fx. So you are expected to find f dash of c, which is limit x tends to c fx, that is sine 2x minus 3 minus fc. So fc becomes sine, instead of x in this, you have to write just c. So this becomes 2c minus 3 by how much? You have to write x minus c. So again, as I said earlier, what you have to do here is you have to substitute, or you have to make, whenever you have got trigonometric limit, you have to make this okay, so you have to change this into 0. Okay, so how to change? You are expert now, isn't it? So let's do that also. So we have limit. Okay, so before we do that, let's do one thing. You know, there is sines, this is my c minus sine d. Now there is a formula from trigonometry which says sine c minus sine d will be equals to 2 cos c plus d by 2 sine c minus d by 2. So this is the very important or very famous formula. Let's apply that first. Okay, after conversion also we need to apply, but here also we can do the same. Okay, so if I do that, this is my c, this is my d. Okay, so this is 2 cos c plus d by 2. So c, that is 2x minus 3 plus d, d is 2c minus 3 by 2 into sine c, that is 2x minus 3 minus d, that is minus of this is minus 2c plus 3 by 2. Okay, divided by, we have got x minus c, limit is still x tends to c. So let's simplify this. So is there anything getting cancelled? Yes, these two gets cancelled, I guess. Yes. Okay, so here we don't have anything getting cancelled. So this will be equals to limit x tends to c. Okay, now this becomes 2x plus 2c minus 6. And if you divide that particular term or expression by 2, then you will get 2 cos x plus c minus 2. I'm sorry, minus 3. Okay, and here it becomes sine, so this becomes x minus c here. Okay, divided by, we have got x minus c. Okay, fine. Now what you can do here is, okay, so instead of changing into 0, you can work with this much also. Okay, now what we are going to do is, we will separate this limit in two ways. That is, 2 is constant, this will be kept outside. So I'll write limit x tends to c cos of x plus c minus 3 into, so basically I am distributing this limit into this and this term. Okay, so that's why I'm writing limit x tends to c sine x minus c by x minus c. Okay, now there's a direct formula, this is equal to 1. Okay, so this is directly equal to 1, so we need not do anything out here. So this becomes 2 into, now you can substitute the value of x to be c. So if I do that, then I'll get 2 cos, this becomes c plus c minus 3 into, how much is this? This is 1. Now when you simplify this, 2 into 1 is 2, and this becomes cos 2c minus 3. So this is my answer for this particular question. Pause the video and note it down. Now this time my fx is going to be a bit complicated, but no worries, your work is going to be the same. So this is your fx, so you are expected to find f dash of c, which will be limit x tends to c fx, that is square root of sine 2x minus fc, that is square root of sine 2c, isn't it? This is f of c divided by x minus c. So whenever you see this kind of sum, try, okay, so if there is minus, see, always you get a problem with minus only. So if you see minus with square root sign, try to rationalize it. So if you want to rationalize it, then this becomes into, I have to rationalize using square root of sine 2x plus square root of sine 2c, and the same has to be done in the denominator also, isn't it? So this is sine 2x plus square root of sine 2c. Okay, so the numerator changes to, so limit x tends to c, so this is sine 2x, so this is square, a minus b into a plus b is a square, that is this, minus b square, that is this, isn't it? So we get this in the numerator. So in the denominator we get x minus c into square root of sine 2x plus square root of sine 2c. Okay, so again we have to apply the same formula, sine c minus sine d, which is limit x tends to c. So sine c minus sine d is 2 cos c plus d by 2 sine c minus d by 2. Okay, so this is my sine c minus sine d divided by, we have x minus c square root of sine 2x plus square root of sine 2c. Okay, so this becomes, okay, now here see carefully, we have limit x tends to c, so 2, okay, so this becomes cos x plus c, isn't it? Check it. Okay, and here we get sine x minus c. Okay, divided by, we get x minus c square root of sine 2x plus square root of sine 2c. Okay, now what am I going to do here is I am going to make two different limits here. As usual, in the earlier problem also we have done the same. Here also we are going to do the same. So this 2 will be first kept outside. Into we'll write limit x tends to c. So first we'll write cos x plus c divided by this term. Okay, so divided by square root of sine 2x plus square root of sine 2c into limit x tends to c, and the other one, what is left? Sine x minus c divided by what is left? X minus c. Now all of you know that this is equal to 1. Yes, so this becomes 2 into. Now we don't have any minus thing out here, so you can directly substitute the value of x to be c. Then we get cos c plus c. Instead of x I have written c. Here also I'll do the same. So this becomes square root of sine 2c, and here also we have got square root of sine 2c. So we have this equal to 1. Yes. Okay, so 2 into 1 is 2. So this is my cos 2c divided by this and this, both are same, so that's why this becomes twice of square root of sine 2c. So 2 and 2 gets cancelled, so your answer turns out to be cos 2c by square root of sine 2c. Okay, so this is your answer for this particular question. So pause the video and note it down. Let's take the last question for the day, which says differentiate this function now. So this is my fx. So as usual, your f dash of c will be limit x tends to c. So this is, tan fx is tan root x minus fc, that is tan root c by x minus c, right? Okay, now if you are searching for the formula like tan c minus tan d, then there is no formula available for such. Okay, so here what am I going to do is simple. See here, I'm going to convert tan theta as sin theta by cos theta. That means this becomes sine square root of x by cos root x minus, similarly this also becomes sine root c by cos root c divided by we have x minus c. Okay, now let's simplify the numerator. So limit x tends to c. So let's find the denominator. Okay, the LCM of denominator. This becomes cos root x cos root c. Okay, so divide this LCM by this, so you'll get cos root c. So the cos root c into sine root x becomes sine root x cos root c. So we have minus. Similarly, when you simplify, you will get cos root x sine root c. So this is the simplification of numerator. Now the denominator can be written as this by 1. Yes, and this division can be written as into. So this becomes 1 by x minus c. Okay, now see here carefully. Okay, so we have limit x tends to c. Now this sine a cos b minus cos a sine b, isn't it? So sine a cos b minus cos a sine b is always sine a minus b. And what is a? A is root x minus what is b? B is root c, right? Yes or no? Now see here carefully. This is there, right? So can I write this as square root of x whole square, square root of c whole square? Yes, definitely I can write this. So if I write this, then this is like a square minus b square. Yes. So if this is my a square minus b square, then I can write this as a minus b into a plus b. So a minus b into a plus b. Yes. Are you understanding? Now let me keep all of them here only. So this becomes a longer one. So it is cos of root x, cos of root c. Okay. Now this full thing is written here. Is there anything left? No. So that's why we'll write 1, and this limit can be distributed. That means you can write one more limit out here. Okay. How much is this? See here carefully and tell me. This is exactly equal to 1, isn't it? So this is my 1. Now you can substitute the value of x to be c here. So if I do that, then I'll get 1 by root, so x is c, so root c plus root c. So this becomes cos root c, and this is already cos root c. Now simplify this and see. This is cos square root c. Yes. So we have 1 by cos square root c. Now this is how much? This is 2 root c. Okay. So that's why your answer for this particular question turns out to be this much. Pause the video and note it down.